and thank you for joining in here live at 3 p.m. CT. The webinar is around AI-powered KYC with the subtitle Potential Pitfalls and Blind Spots. First of all, some practicalities. The session is being recorded, so anyone who's not able to join, or if you want to even review, you can do that and find the link from our website. For those of you who are here today, if you have any questions, just use the Q&A button, and you can find it in the Zoom toolbar below. And with that, I'd like to just give a quick overview of the agenda. So we have more or less 3 blocks, and we expect to speak around 35-40 minutes. That's typically a good timing for a webinar like this. But the first block will really be about a foundational block around what is AI, what are the models we see, and some insights from Ahmad on that one. The second block is around our principles for deploying AI on the KYC platform, but also the use cases we see across KYC. And finally, the third block will be around what are the pitfalls, risks, blind spots. We'll talk a little bit about more both operational and technical risks, a little bit about legal risks, and what wouldn't we use AI for in the KYC landscape. And then, of course, any potential questions along the way. So with that being said, let's just have a quick introduction, and I'll gracefully start with myself, actually. I'm the co-founder and CEO of Avallone. Been doing it for 5 years. Before that, I've been in banking for almost 20 years, both commercial roles within the large corporate institutional segment, but the last 7 years of my banking career on the darker side in terms of compliance and financial crime prevention, being head of op risk and compliance for Nordea out of Stockholm and head of compliance for Danske out of Copenhagen. And now I'm here today. And with that, I just want to give the word to you, Ahmad, to introduce yourself.
Yes, thank you. I'm Ahmad. I am the Director of Engineering at Avallone. What that means is that I'm responsible for the day-to-day operations. I'm involved in the product strategy, and it's basically building and maintaining the platform. Before Avallone, I was working at Microsoft. Most of my career, I've been working with startups. I was the first engineer to join Pineo, which is a Danish company. We were building signing solutions using digital signatures. My formal background is in security. I'm a software engineer at heart, and working in compliance and KYC is a natural fit for me. So that's it.
Perfect. Thank you so much, Matt. Very nice to have you here today. So let's start out with the first block, which is really the more foundational block, which is what is AI? And I'm absolutely going to give the word to you, Ahmad, to just take us through this part of the session. So if you want to take it from there, and maybe I'll just move to the first slide on that.
Yes. So AI, it's a buzzword lately, right? I'm going to explain it in a way that I can understand myself. So it's a term that has been thrown a lot lately, but AI has been around since the 1950s. It's not something that's new. What it means is technology that refers to machines designed to analyze data and make decisions on that data. But basically, what separates it is performing any tasks that kind of mimic human intelligence. The thing is, lately we've been talking about Gen AI or generative AI. And what sets generative AI apart is that the machines can not only just analyze data and decide, but they can also generate content. Content would be text, audio, video, code, and it's getting really interesting. Because of the recent advancements, we're just getting to a point that the output that we're getting from these machines is matching levels that we basically can't distinguish between humans and machines, and that is why it's there's so much buzz around that. But basically, in order to talk more about AI, I have to introduce the concept of a model. So what is a model? A model is basically the brain of AI. If you can go to the next slide, I have some bullet points on it. And it's a piece of code that does some computation, just like conventional software. It takes an input and it gives you back an output. The thing is, it's like a black box, which means that we can't really explain how it works. Again, it's similar to how our brain works. We can think using our brain, but it's very difficult for us to explain how the brain is working. The way models work is that they don't need explicit instructions. Instead of giving them explicit instructions, we train the model by showing them examples. And by looking at a lot of examples, the model extracts patterns from these examples. Basically, it's pattern matching at scale. And the model is able to extract, or basically the model is the essence of all the patterns that it sees. What we can do is we can tweak it, we can get better results, but then again, it's very difficult for us to explain what's going internally. We'll talk a little bit more about models, but just to make this concept tangible for you, we move on to the next slide. Where can we find these models? A lot of companies are building these models, but one place that I like a lot is this repository of models called Hugging Face. I like this because they've categorized different models based on what they're good at. So here you can see a few categories. You can see models that are good at audio and text, natural language processing, and so on and so forth, translations and image detection. It's just a fun place to go and visit and see all the different models that are there. And not just that, but you can also see the licenses and the data that those models used, whether you can use these commercially or not. All right. Now let's go to the more interesting discussion, and that is that if we've been talking about AI since the 1950s, if this term has been out there since the 1950s, why is it that in the last couple of years there's so much buzz around it? And basically, it leads to three different things. If you go to the next slide, Anders. The first reason is that we have better algorithms, and then there's this seminal paper called Attention is All You Need, which is, in some sense, was the tipping point where a lot of things started to change significantly. So we have a better algorithm, and there has been a lot of advancements in that area. But the second thing is that we have more data to process, and we are able to train our models on larger data sets. And the third thing, which I believe is extremely exciting, is that we just have more computation power. And we can, with all the data sets that we have, we can just train our models using more computation. And these three things combined lead us to this tipping point, as I've said before, that the results are becoming to look very interesting. In the past, we used to have this test called a Turing test, which was a way for us to distinguish between a human and a machine. But that test, we can't really rely on it anymore because it's almost impossible to distinguish what's a machine and if it's coming from a human. So we're living in remarkable times. The last point that I want to mention before we move on is the dilemma that we have. We have this amazing technology that works fantastically. We can see the results, but we just don't have a way to explain how it works. Again, just like my brain, I know how I can think, but I don't really know how I'm thinking. I know that there are certain neurons in my brain, and I know that every person has a different configuration of those neurons, but we are not really sure which architecture or which pattern or which configuration of that model leads to better or worse results. All we have is empirical evidence. So it's kind of like dark magic, that something works, but how it works, it's difficult to explain. Anders, over to you.
Thank you, Ahmad. That was thank you for a good, comprehensive, but also fairly short intro. And as I think you also wrote in your post today on LinkedIn, you know, there are many AI experts out there, and there's a lot of webinars and talks and blogs you can read about it. So it's really absolutely in focus at the moment, right? With this in mind, we wanted to move on to kind of like the more concrete, where we combine what AI can do today and the use cases within KYC. Before going to the use cases, we're actually going to still stay with you a little bit, Ahmad, and talk a little bit about the principles for how we've chosen to deploy AI. And then we can actually go into, with those principles in mind, then I'll talk a little bit to the use cases we see in the domain of KYC. So maybe could you speak a little bit to this?
Yes, absolutely. It's a technology that's in early stages. The results are amazing, so nobody can ignore that. I mentioned that there's a problem with explainability. So with that in mind, the principles that we've chosen in Avallone are the follows. Number one, the features that we built in Avallone, they're going to be opt-in. We are never going to enable an AI feature without the user's consent. So even if we build something, it's always the user's choice to come in and enable that feature for themselves. Number two, we are implementing a bring your own license model, which means that the users can choose their own sub-processors, their own models. They have more control on how they want to use AI. The third one is that we always use AI as a wingman or wingwoman, wing person, whatever you want to call it. So we support and enhance the user's workflows, but we don't replace it. The human being is always going to have the decision at the end. The third thing is that we want to explain how we got to a specific point. Even if the AI can give you some suggestions about what good outcomes are or what suitable results are, the human being should be able to click on the source of that content and verify if it makes sense or not. If the human beings cannot verify what the AI is doing, then we choose not to use AI. So we need to make sure that the human being is in control. And last but not least is that we start small. We develop incrementally. We are identifying areas where things are getting repetitive and monotonous, and we would replace that by AI, and we'll have some kind of a view that lets the human being either accept what they see or reject what they see. But we are taking it one by one. It's kind of like sprinkling AI all over, and our hopes are that at some point it's going to have a compounding effect. But we are taking it one step at a time. And we want to do it in close collaboration with our users. So these are the set of principles that we are adhering to.
Perfect. Thank you, Ahmad. So with this in mind, then let's talk a little bit about how we see some of the use cases. And we don't have slides on all of the use cases, so I think I'll just stop sharing, and then we can reshare some of the slides again to explain. Those from the audience that know Avallone, you also know that we split KYC into two. We have KYC response and we have KYC collect. And just to remind, KYC response is the task, the challenge for the user to respond to KYC requests coming at them from, for example, their banking group, thereby finding the data and the documents they have to share, answering questions, sharing that in a safe way, communicating back and forth with the requesting party, so typically the bank. The other part, the collect part, is what people would usually call the conventional KYC, which is how do I collect data and documents from a counterparty, customer, vendor, investor, whoever it is, and start to review it, perform risk scoring, decision making, screening, all of that stuff. So that's the two sides of the Avallone platform, and the AI use cases are quite difficult from one to the other. So if we start on actually the KYC response side, so there, as to your point from before, Ahmad, we start like task by task or challenge by challenge from seen from a user's point of view, and we try to automate that. Now, the means to automation can be AI. It could also be something else. And it goes from, I think, looking at it one by one, it's a little bit underwhelming. It's like, okay, yeah, that's smart, but it doesn't change my world, right? But when you start to add up all of these underwhelming things, it starts to solve a larger and larger proportion of your process. It becomes pretty overwhelming, or a very, very big help. So it's the sprinkling you mentioned before, Ahmad. We just sprinkle one at a time, and suddenly it's a sprinkle, right? So to come with some concrete examples, in the responder process, you typically get an email from your bank, and that email contains requirements, what you need to deliver in terms of documents. It may contain a questionnaire, and then you start to work on that. The problem is that typically the receiver of that email is alone, but they are depending on a lot of other people. So a very basic thing we've deployed is for the AI model to read the email and digest that and convert that into tasks, including tasks with due date on, and thereby showing you in the sidebar of the platform, hey, this is what you need to do. I've interpreted the email. These are the requirements. This is what you need to do in order to satisfy the request from the bank. That also includes, like, if you already created some of the tasks, hey, this is a duplicate, you don't have to create it. So really thinking about how do we just in a very, very operational way help the user. Now, at this point in time, the user will take over and actually start to delegate these tasks to their co-workers or their colleagues. Now, of course, AI could also help them with that, but it becomes a little bit more complex. How would you know that this person is in legal and this person is in procurement, or whoever you're dependent on? And if we continue down that route, there's a massive opportunity in the interpretation of the questionnaires, because this is really where we see the large language models having an advantage, where reading a question, looking at your previous answers, and then actually starting to answer those questions that you get. And coming back to your point, Ahmad, with explainability. So being able to show the user, I think two things, and maybe you can comment on that actually. One thing is, how certain is the AI model that it's answering the question the right way? And secondly, the source of the answer. Where does it come from? So can you speak a little bit about that part of the technology?
Yeah, so what you're referring to is it's a very common problem. How do you do source attribution? If you get an answer back, how can you connect it back to the source? So the technology is limited in the sense that it can also hallucinate, which is a strength and also a weakness. It's a weakness because you can't rely on it on fact checking, but the strength is that it mimics human beings. But anyway, if you get a response back, you need to be able to say where that response is coming from. And there's a pattern being used in the industry called the RAG, which stands for Retrieval Augmented Generation. And the idea is that the data that you use to search on, you first need to store it in a way where you can do semantic search on it. there's a concept of embeddings. You can take all of this text and you can convert that into numbers, which has this magical property. The magical property is that you can compare numbers based on how near they are. But using the process of generating embeddings, only then you can have these numbers where you can cluster them based on how similar they are in terms of meaning. Once you do that, once you have generated the embeddings, then basically it's comparison of different embeddings. We need to store those embeddings together with the sources. So that's a lot of techno babble. But in the end, basically what it is that when you search something, you also, when you store these embeddings, you also store the sources. And when you search these embeddings, you also pick back those sources so that you can show to the end user where the content came from. And then the user is free to click on those links and verify for themselves if it makes sense or not.
Exactly. And I think also in this space, you can't have that your platform is hallucinating. You can't have that it's guessing, right? So you need to know when it can't answer with a certain probability the question, because then it's probably because it doesn't have the answer, and then you need to add the answer. And thereby you can, of course, add data to the model, and thereby the next time it has an answer, right, to a similar question. So I think that's why we talk so much about explainability and the certainty of the answers, right?
Exactly. So even if the model is hallucinating, just by providing you with the source, we also give you the option to verify if it makes sense or not. And then you can verify it for yourself. And there are certain domains where being creative makes sense. But in KYC, it's a weakness, right? So we need to cater for that.
Yeah, exactly. And I think just rounding off on the responder use cases. So also coming back to our principle of AI being the wing woman, a wing person, a wing man, whatever your preference is, but that in the end it will be a human being that pushes off the package, that pushes off the sharing, right? Because we don't want the platform that just like, yeah, I did everything and no one was involved, because companies are sharing out pretty confidential information, first of all. Secondly, it's pretty important that you answer your bank accurately. Some of these questions is also related to sanctions, right? So it's not something where you want to guess, you know, are you conducting business with Russia or Iran or whatever. You want to have pretty strict governance around those answers. So this thing with having a forced preview before you share, both in terms of the package you share, but actually also on the answers to the questions in the questionnaires. A small nuance to that is also that the regulators are starting to rumble, not because of AI, but just because in general, the involvement of platforms, where we see also like the German regulators starting to say, hey, listen, if it's a platform that just answers it, we need some sort of confirmation that there's actually a human being saying, hey, I answered this questionnaire and it's me. You know, they want accountability back into the person. So there is having new technologies and using that as much as we can to help the user, but actually adding it with pretty old school controls, which could be a document signed with DocuSign or whatever from a person that's like, okay, we can see that a person has been involved and they take full accountability of what's being shared. Listen, looking at the time, let's just jump to the more conventional side of KYC, which is the collect side. And I think that's also where there's a little bit more noise around how AI is being used. A lot of talk about AI agents that can do subtasks. I just want to share the first example where we deployed AI, which we think looks pretty interesting. And this is, you should be able to see now, a legal entity structure. Can you see the slide now? I'm not just checking.
Yes. Yep.
Perfect. So this is a classic example of when you work with a little bit more complex structures, which is our domain in Avallone. So we don't focus necessarily so much on the consumer KYC, more straight through processing, simple flows, but more like when you have these more complex structures. Now, typically you would then receive, hey, I need to understand your ownership structure, and then maybe your customer or your investor sends you a slide that this is an ownership structure. And by the way, this is not a complex structure as such, but just for the example of it. What happens today is that whoever sits and collects this, whether it's a bank or a fund or corporate, they would then start to sit and manually ingest these names into a screening platform, start to decide who they need to collect additional data from, figure out UBOs, etc., etc. However, here we see good results with AI, where you can actually have the AI, you inject the image to the AI reads it and actually then transform it, and this is from the Avallone platform, transforms it into a legal entity structure that is live data, so to speak, and structured data. And this means that in a flow, and this would take around 10-15 seconds computation time, you then suddenly have all of the parties in the platform as related parties, and you can just kick screening off and get the results in one go, instead of this keying it in manually. So there we see a huge potential in those cases where you would typically sit manually and do it. And then I think when looking at other less complex cases, and this is really where I see a big potential, is when we focus on, so if you split KYC up into the three basic elements, you have information, documentation, and verification. So information, and to some part documentation, you would typically, or not to some part, information documentation, you would typically get in an outreach. You reach out to your customer, to your investor, and you ask for it. And of course, then you can get part of that in the public domain. That's a whole other discussion around the strength of public data. But then you sit with it, and then a KYC analyst starts to look at it and, hey, do I need to get verification from an independent source, etc., and they start to work on that. And especially that part, we see huge potential where you can take and instruct an AI agent to say, hey, I have a certificate on incorporation. I already received it. I need you to go check to the original source, which could be the public database in Denmark or the UK company house, and compare and see if that's the right one. That task is boring, it takes a long time, and it's just not enjoyable for the person. So if you can actually have a wing person, an AI wing person to do that, that would be enormously helpful. See, we're not trying to then say, hey, it's the entire process we deploy AI on, because then it's like, how do you instruct one, say, hey, you need to do outreach, you need to ask the investor the right questions, you need to analyze that, you need to ask for the right documentation, you need to then verify that documentation. It's a super simple complex or super complex process where you're depending on a lot of different sources. But by doing it one by one, we actually believe you get a much higher success rate. And I think this is also where one of the principles you mentioned before, Ahmad, of user interaction. So we are actually not sure which, we have a pretty good idea, but we're not sure what would give the most value to the user. What is the most annoying thing they have? In this way, they can direct us much more easily and say, hey, listen, what we typically do is the certificate of incorporation. That's the worst thing. So if you can remove that, it will, just remove 30% of our pain point. If you then also fix this one, you remove 50% of our pain point. So this way we get much faster to value and higher impact. So that's a little bit how we think about the use cases. So we see use cases mostly within the verification space, to some degree also the documentation phase or space, also comparing. Of course, you can say, hey, I get this information from the outreach. Can you please compare with another data set you may have? What are the discrepancies? Also not super complex, but still complex to build if you want to do it across all of the many different use cases you have. And I think here, Ahmad, more, I hate the word modern technology, but really, I guess that's what it is, right? The more modern technology in terms of AI starts to be combined with just old school API work. right? I mean, how do we hook up to the different databases? Because you can't just ask AI to get into any public database. Many of them requires a login. Many of them require some sort of, permission to be there. And that's actually something that's growing with the development of GDPR legislation across countries, right? So you have to combine old school with kind of new school.
Totally. And to that, I think you quickly alluded in the beginning of the discussion that that AI is a tool, right? It's a means to an end. And we are focused on delivering value. We are focused on solving the KYC problem. Whether we do it with AI or conventional tools or manual processes, we don't care. We want to solve the problem of KYC. And this just happens to be a technology that's giving us good results. So we're exploring it. So I completely agree with you.
Here. Okay, time is flying, and especially when we talk about use cases. So I want us to jump to the last section, Ahmad, of the kind of the pitfalls, blind spots, risks. And let me just also quickly share my screen because we have a few slides on that. And I think just starting with the core risks, Ahmad, let me share my screen. If you can just start to talk a little bit about that one.
Yeah. So risks when it comes to a new emerging technology, there's no end. But we are thinking about it in three different aspects. There's some operational risks. First of all, if we are the experts in KYC, right? We're not experts in AI. We are trying to understand AI, which means that we need to leverage the expertise on people who really build these models and understand these models. Companies like OpenAI, Anthropic, whatever have you. So there's some dependency on third-party AI models, which means that they have some control. The models are maintained by others. And in some cases, the only way to access those models is through APIs. If you start relying on a model and there's a new version, because of the way these models work, we cannot ensure backwards compatibility. There's just so much non-determinism happening. And licenses can also change. Your access to these models can also change. So we need to keep that in mind before we start using such technology into our, before we bring this technology into our platform or into our infrastructure. The technical risks are that models, by their nature, they hallucinate. They are not always factual. If you ask a model what's 2 + 2, the only reason why it's going to give you 4 is because it has seen that pattern so many times before, but it's not doing computation itself unless you instruct it to delegate that to a more conventional software system. So I mentioned this before, responses are not deterministic. Explainability of the inner workings is an issue. And then last but not least, compliance. If we start using this new technology, of course, we have to go and update our data processing agreements, and we need to keep an eye on the evolving regulations. So I think I would end there. Anders, do you have something to add?
Yeah, I think just when you mentioned before the licenses can change, I think that's also why that's at least also how we do it. But I think also if you're procuring software, you should ask those kind of questions. Is that also because we have the opt-in principle, right? So if for some reason I don't want to utilize AI, or for some reason suddenly something changes with the licenses in the background, so that you as a provider can't use the sub-processor, then you have to be able to perform your tasks manually, right? And and I think that's why I think there's much more opportunity for us as a company in AI than there is risks or challenges, because there still needs to be a very, very strong orchestration interface for the user, where you can go and say, okay, now I want to collect KYC from an investor. I don't want to deploy AI, so I want to perform the verification myself. I want to collect documentation myself. I want to compare data sets myself. So I think this is an important way to mitigate that risk. Then I want to add a little bit around this thing that it's non-deterministic, and maybe talk a little bit about what I wouldn't use AI for if I was working in the KYC space or as a compliance officer. So to start off with, the big thing, I would not deploy AI on my risk scoring model. I strongly believe a risk scoring model should be a logical model that has extreme high degree of explainability. So if a model flags me high risk and it flags you low risk, Ahmad, it has to be able to explain, okay, how do you get to that? And if it flags me and someone else who is equal high risk differently, it's a problem. So there should be no guessing in the risk scoring model, and I think that will also be a huge focus area for the regulators, right? I think so. Risk scoring, I think that's one of the last things I would move into. I also think we've seen actually also in some regulatory responses that AI used for closing of alerts, like transaction monitoring alerts, they have simply not been strong enough to explain why these alerts have been closed, and some institutions have been forced to reopen all of the former alerts, which is obviously a lot of double work, right? And then so I guess what I'm coming to is, I strongly believe a human making the last decision making, right? And this is also, and this I think will be our last part, just discussing a little bit about the legislation on its way. But when AI models are deemed high risk, that's where there starts to be a high degree of decision making. So I think there's so much to solve with AI before we even get to decision making, before we even get to kind of risk scoring and stuff like that, just to fix all the basic stuff, right? So I think that's where I would focus, and maybe a good segue to the last part, the legal perspectives, right? So we spend a lot of time thinking about, hey, what does it mean to introduce a new sub-processor? And this is what also when you procure software, you should be super mindful of. So when you start to deploy a lot of different models, there's a lot of different sub-processors, and your data starts to flow to different places, right? So there's definitely a legal perspective to it. And this is also where bring your own license can be very critical, because then you can actually bring a closed model where you can control the data flows. And then in the EU, we have the AI Act. The compliance deadline is in 2026. And of course, there they have a risk rating. And even, Ahmad, you and I discussed even today, like, where would we as a KYC platform fall in? And it's very difficult to determine just off the bat, because you really have to look at it feature by feature, right? But again, the moment you start to perform decision making, or large scale risk scoring, you end up in the high risk. But if you stay on what I spoke about before, hey, can you verify this data point? Yes, and is this at a probability? Can this be verified? Yes, no. Then I think you'll be in the limited risk. But this is to be seen. But I think definitely what will very quickly come out as good behavior or base behavior is that you have a log of every time you deploy AI in your platform. What is it doing? Why are you doing it? And why do you think it is limited risk or high risk? So kind of starting to categorize every time you deploy, so you don't have a model with like 20, 30 different agents, and some of them are doing high risk, some of them doing limited risk. I think will be important.
Yeah, Anders, I think it's important to call out here that it's not our categorization where we say something is high risk or low risk. It's the EU AI Act that requires us to, it has certain levels, right? Certain risk levels. Right?
Yes, spot on. It's defined upfront. But I think, like with any legislation, especially legislation that's so fresh off the press, there will be so many use cases like, but hang on, what is this? Because I'm doing scoring of some sort, but it's not, but you're absolutely right. And that's the one you should follow, because otherwise it'll be hard to explain. And I think the reason it's important for us is the moment you start to work with more complex clients and clients that are regulated, that's going to come as a requirement. They're going to start to ask questions like, "Hey guys, what are you doing?" Because they will be also under same obligations of the EU Act. Hey, listen, we are getting closer to quarter two, and we actually said this would last around 40 minutes, but typically, typical us, Ahmad, we can't shut up. So I just want to, because we have 3 questions coming in. I just want to at least choose one of them. I think there's actually a question about RAG. This goes to you, Ahmad. Can you explain AI RAG again? Why is this different compared to normal AI? Normal AI is written like this.
Yeah. So I think we briefly touched on the concept of RAG. RAG stands for Retrieval Augmented Generation. Normal AI, I'm assuming now that by normal AI you mean that when you go in, let's say it's the most popular example is ChatGPT. You go in, you add a prompt, and then you get a response back. Now that response is purely text, right? And I'm assuming that by normal AI, that's what you mean, that you're getting just text back. The problem with that is that how do you know, can you trust that answer or not? That's the problem. Now, there are tools out there where you can add you can write in your question. It gives you a response, but it also gives you a source to where it got that answer from. Perplexity is one good example, which is the up-and-coming search engine. So basically, from what I understand, is that the pattern that they use to implement source attribution is RAG. And at the end of it, you're getting back a response, and you're also getting a link. The link is used to verify the facts. This is called the source attribution. Like you can attribute the answer to the source so that you can go and verify it yourself. So in simple terms, RAG is that technical pattern that we would implement to give you source attribution so that you can go and verify these things for yourself. We can get into the technical aspects. It goes back to the same discussion about embeddings, how you generate them, how you store them, what do embeddings mean. It allows you to do semantic search, all of that fun stuff. But I hope that I just gave you the answer about why it matters.
I think that's a good answer. And then I think they should find another abbreviation than RAG. It's impossible to remember. Yeah. Thanks a lot, Ahmad. Hey, as just ending off, we always end our webinars with like a quick, like, what's your best advice to part with? And I'm not going to give mine, so I think it's more important to hear yours. So Ahmad, if you give like the best advice to the people listening in, what would that be?
Yeah, I would rely on our principles again. But what comes to mind is start small, get into an experimental stage, experimental phase, identify existing processes, improve those first, work closely with your customers. There are going to be cases where it won't work, but then you learn incrementally. Invest in understanding how AI models are working and how this space is evolving, including legislation. And choose vendors who deeply understand how the industry is evolving. And I would say the last thing would be that build systems where human beings are in control. And as long as we use AI to assist in the processes, and then they don't make decisions themselves, I think we can use this technology for a lot of good.
Amazing. Thank you so much, Ahmad. So I think this brings us to the end of it. For those of you listening in or hearing this later at the recording, you're more than welcome to reach out to me or Ahmad directly. You can find our contact details on the website, avallone.io, or you can reach out at hello@avallone.io. And then, keep in touch. We have more webinars coming out. What you heard today is our opinion right now. Especially in this space, it changes pretty fast. So when we learn more, we're definitely going to do a sequence. I think you and me, Ahmad, talking a little bit about AI and the direction we've taken and how far we've come, probably in the new year. So we'll be back. Until then, thank you for joining. Thanks a lot for your time as well, Ahmad.
Yeah, thank you so much, Anders. Thank you.
Cheers.